as our usual webinar. The interesting topic, as all of you know, electric vehicle, fire in electric vehicle. We have an young and knowledgeable person as a speaker who will be explaining more on electric vehicles on the subject. But to introduce you, NFE, all of you know very well, NFE stands for National Federation of Engineers for Electrical Safety. We are a registered society, and our aim is to create awareness on electrical safety, electrocution, fire from electrical usage or electricity usage, protection of the electrical installation. Basically, we are talking on electrical safety. As all of you know that in India, an average of 13 to 14,000 people get killed due to electrocution. And on the other side, fire. Probably most of you are aware of the yesterday's terrific incident in Jhansi, UP, where 10 children, newborn babies, were they were affected because of the fire in the IC unit. So such incidents are very common in our country, and these are this is unacceptable. We should work together, and we should ensure that our nation is protected from such accidents, or installations are protected from such accidents. So for making this, we have a lot of gaps. One of the gap which we are trying to fill is creating awareness. Yesterday we had a one-day seminar in Thiruvananthapuram. We had more than 150 participants, very interesting session, and there was an exclusive session for almost 45 minutes on hospital fire yesterday evening. So now you are aware of our website nfees.org, where our vision, mission, and what we are doing are very well explained. Our vision is to make the nation electrically safe. Mission, we achieve our vision through education. We are conducting awareness programs. You can also find the membership, join as a member. You can find out the membership. You can become an individual member or a corporate member or a MSME member. There are several options. There is a small fee, one-time registration fee, 500 rupees for individual member, and an annual fee of just 1,000 rupees plus GST. Altogether will be something about 1,700 rupees. But this is very much, this membership fee is also necessary for us to survive, because we are surviving because of this small fees, and with our efforts we are making a lot of training classes, as you know. Today's subject is electric vehicle safety. We have an interesting speaker, Mr. Govind. He is a specialist in electric vehicle hazard electrification, extinction trainer for Kerala Fire and Rescue Service. So all of you know very well me. I am Gopakumar. I am the president of NFE. I have been associated, or I have been conducting classes for several decades now, maybe more than 2 decades. We have today's our speaker, Mr. Govind. He is a motivated engineer specializing in EV safety and hazard management, with experience designing safety programs on fire risk, battery suppression, and extrication as an EV trainer with Kerala Fire and Rescue Service. Previous role includes sales associate with Prabha Enterprises, delivering electrical solutions, and business development associate at Think and Learn Private Limited, promoting EdTech solutions. With certification from IIT Bombay and Encole Des Point Paris Tech, and BTech in electrical and electronics engineering. He is an expert in ANSYS Maxwell, MATLAB, EV charging, BMS, and electric drives. Key points include BLDC motor design and two-wheeler and magnetic component design for UPS systems. So we have a very well experienced and young speaker for today. Now let's hear from him what he is going to talk on. electric vehicle fire. Over to you, Mr. Govind. You can start.
Good morning, all. Hope everyone is doing fine. So, in today's session, we'll be covering regarding electric vehicle safety. As you all might know, electric vehicles is a relatively new sector, but it is booming in India as of now. So many people might have skepticism. Will electric vehicles be the future? Will EVs last? Are they actually green? And the most important aspect when it comes to us as safety experts, how do we conduct electric vehicle charging sessions properly? How do we use electric vehicles in such a manner that they become much safer than the conventional mobility solutions? So these were the points that I'll be taking on. So we'll start the presentation.
Yes, please. You can share the screen.
I hope my screen is visible.
Perfect. Go ahead, please.
So let us just start off with electric vehicles. Many of you might think that electric vehicles is actually a new technology, but when we decode into the major components that is used in electric vehicles, that is motors and batteries. Powering mobility solutions using electric motors is not actually a new concept. In fact, this technology is more than a century old. In around 1900s, electric vehicles were the main source of commutation apart from horse-driven carriages in major cities like New York and London. These electric vehicles had relatively small battery packs and motors, and they had a range of around 50 kilometers, which is almost nothing when we compare to modern day EV standards. These vehicles were used as taxis primarily in cities. And a major reason why electric vehicles were used at the time was that petrol or internal combustion engines were complex and very expensive at that time. So if I show you this photo without a context, you might not think that this is an electric vehicle. But if you pay close attention to the bonnet area of this vehicle, you can see that there is almost nothing sticking out because this is actually is an electric vehicle from the late 1900s. So many of you might ask if electric vehicles was a new technology, was a very old technology, then why are we having this session now? Why is electric vehicles being relevant now? Now, what happened was that electric vehicles were common at that time due to uh, affordability and lack of common internal combustion vehicles. Then later, what happened was that a manufacturer called Ford, they started the assembly line process when it comes to ICE vehicles and launched a model called Ford Model T. This became the best-selling car of that century. They didn't have any sort of pollution laws at that time, and electric vehicles was history. So this was the basic prologue to electric vehicles. Now let us see how electric vehicles become relevant in the modern day. So as you might know, fossil fuels are getting depleted, and we have to look for another source of mobility. Global warming and environmental pollution is also increasing on the rise. Major cities like Delhi, Bangalore, Mumbai are all facing severe air pollution. And also, as you might know, for the common man, fossil fuel prices are increasing and they're struggling to make ends meet when it comes to mobility. So this was the major driving force regarding looking for an alternate solution. And that is how we started to revisit to electric vehicles. Now let us consider how electric vehicles are relevant in the modern day. When we look for more than 100 years, we can see that there is a widespread availability of electricity nowadays. A common dialogue that I use when it comes to promoting electric vehicles is that petrol is centralized. You need to have petrol in sort of places to power mobility. But when it comes to electric vehicles, electricity is everywhere. What EV charging manufacturers and what electric vehicle manufacturers need to do is that they need to figure out a way to get this electricity in a safe format into vehicles so that mobility needs can be met. Now, this is actually easier said than done as there are certain complications which are bound to happen regarding this. This is one point. The another major point is that at that time it was primarily lead acid batteries, but as you might know, now there are huge innovations happening in the battery sectors. Currently, lithium-ion battery packs are used for electric vehicles. In lithium-ion battery packs itself, there are further classifications, which we will dive deeper into the session once we start it. And afterwards, lithium-ion battery pack will be replaced with other coming technologies also. So many people might ask, will hydrogen actually replace electric vehicles? Actually, hydrogens are electric vehicles. For fuel cell electric vehicles, hydrogen is a source of fuel. It generates electricity and it stores into a small lithium ion battery pack. This electricity is then used to power motors and mobility is thus met. So it is the source of fuel, whether it's a lithium ion battery pack, whether it's a solid state battery pack, whether it's a carbon graphene battery pack, or whether it's a fuel cell, that will be changed. But the ultimate goal that electricity will be produced inside the vehicle or stored inside the vehicle and will be used to power the motors will remain the same. And afterwards, what happened was the power electron, the term which I used to recollect is power electronic revolution. As you might know, earlier for more than 100 years, they were basically transistors only. We didn't have computing chips or anything like that. But now, with AI technology and everything relevant now, electric vehicles are able to operate in a much more steady manner. Just to put into a concept, an electric vehicle which has proper power electronics, which has been tuned for efficiency, will have up to 30% better performance and range when we compare to a rudimentary electric vehicle with a normal drivetrain itself. So these are the advancements that were happening in the electric vehicle sector that made it very feasible for us. Many of you think that our electric vehicles are actually green because what we do is that we burn coal. In India, as you might know, coal is the major source of electricity. In thermal power plants, we burn coal there and we transfer this electricity into our cars. So, in a petrol car, I am polluting when driving. But in an electric car, am I not polluting in the power plant? That is a very valid question. But the major point that we are forgetting is efficiency. Internal combustion engines, when they are deployed in normal vehicles itself, the maximum efficiency that they can use is around that they can reach is around 45 to 50%. When we compare that with an electric drivetrain can anywhere have between 80 to 95% in efficiency in real world testing conditions itself. So even if we are burning fossil fuels to generate electricity, our efficiency is going up significantly and we are able to thus reduce pollution. Now let us see how electric vehicles really become carbon neutral without any sort of pollution. That is where renewable energy production comes into effect. Now, before I explain the renewable energy production, I just wanted to share a real world example with you guys. In the Union Territory of Lakshadweep in India, there are no petrol pumps. People there have to rely on ration shops to get their petrol so that they can meet their mobility requirements. Now, there are companies which have set up slow powered AC charging stations in Lakshadweep. They have multiple solar projects there. Using the electricity generated from solar photovoltaic panels, electric vehicles are being charged. Electric scooters are being used in Lakshadweep, and people thus gained energy independency. Now, let us just imagine that concept a place which was very remote, which is very difficult for us to get the fossil fuels conventionally. But we are able to make electricity from that place using renewable energy systems itself. And using that energy, we are able to sustain our mobility requirements. So that is the beauty of electric vehicles. We are able to generate electricity also on our own. Well, when I'm interacting with people when it comes to electric vehicles, many people ask me, right now, petrol and diesel is costly. But when electric vehicles becomes the industry standard and norm, then won't the authorities and governments increase the taxes and tariffs on electricity and thus making it difficult for us? Yes, that is a possibility. But however, we have the method of producing electricity of our own. But when it comes to fossil fuel, we can't produce fossil fuel at our own place. So when it comes to renewable production of electricity, we can actually solar is one of the methods. Many of you might be aware there are other methods such as windmills, tidal. geothermal. Using these methods, we are able to generate electricity, which will actually reduce pollution significantly and overall reduce the cost that we bear. Thus, we can achieve a very neutral carbon footprint. Now, when it comes to India, let us see the EV picture scenario of India. Many of you might be seeing that electric vehicles is a new sort of industry with the green number boards and everything. But if we actually look past into the future, we can see that electric vehicles are already there. India had the first electric car, the Reva E2O, from around 2003. From well into the 2010s, people were using electric scooters for mobility. Tata and Mahindra had their first electric cars in around 2017 to 18 time. But it is past 2019 that high voltage electric vehicles started to dominate India. Now, I am using this word high voltage for a very specific reason. As you might be able to see, consumer demand for electric vehicles increases. The major requirement will be range and power. To get more power from electric vehicles, manufacturers use high voltage architecture. Now, it is very obvious that the safety risk that is associated with an 800-volt electric car and an electric car operating on a 72-volt architecture is very different. So, when we go deep into the session, I'll be also explaining the impacts of this high voltage electric vehicles. Government also started introducing electric vehicle charging infra, and the EV industry in India started to take off. So these are some of the electric vehicles that are being sold commonly in India. Now, currently, Tata Motors is leading the pack. JSW MG Motors is second. When it comes to electric two-wheelers, I have chosen these three photos for a very specific reason. The first two vehicles you most might be aware of, they are Ola and Ather electric vehicles. Their battery packs are positioned on the floor. The third one is a Hero electric vehicle, which is a kit model assembled vehicle. Their battery pack are assembled in the boot. The first two electric vehicles are based on a relatively high voltage architecture, and the latter is on a relatively lower voltage architecture. The safety aspects and standard that these two electric vehicles meet are actually quite different. In the third vehicle, we'll be able to remove the battery pack in case of a fire. But when it comes to the first two vehicles, as the battery pack size is high and packaging is a constraint, this is not a possibility. I'll in detail explain regarding the role of battery pack position and how we can detect an electric vehicle fire, which is when it's happening, whether it's associated with the battery pack or with any other component in the vehicle. Deeper into the session, I'll be explaining that. Now, let us start the introduction for EV charging. Now, while explaining this, many of you have might get doubts when it comes to electric vehicle charging and the safety of EV charging safety. So, after 1 hour session, we can have a detailed look about on this. Now, primarily EV charging is categorized into three levels. As these levels progress, the safety aspect becomes much more rigorous, the power input increases, and the investment cost also increases. So let us see level 1 charging. Now, level 1 is the most basic EV charging. It consists of charging an electric vehicle at any household power socket. Don't need any sort of additional wiring while constructing a level 1 charging system. Now, while explaining this, many of you might get a doubt. If you are using a household power socket, how can we ensure the wiring inside the power socket is actually safe? Many of people might be residing in homes which have socket or electrical wiring done, which is more than 20 years old. Now, how might we know whether the copper cable passing from the power socket to the mains is actually really good? And also in level 1 charging, since we are only relying on a 16 ampere socket, the energy power output is almost very slow. When it comes to electric cars, it takes anywhere from 10 hours to more than 25 hours depending upon the battery capacity. So without question, people will be charging the electric cars at night. Now this raises a question. If my electric car or electric scooter is charging at night and a fire incident or a short circuit happens, I'll be sleeping. So will my response time be as good when compared to a daytime? There will be family members or didn't understand that. There will be also family members in a home. Generally, when we look at this, what will happen when electric vehicles are being used for other situations? There might be a scenario where electric vehicle fire happens and it's in the middle of the night. The fire and rescue officers might also take a while to reach there. The chances of electric vehicle fire hazard happening and people dying are actually quite high. In India, actually, no person has died because of the electric vehicle fire. Casualties have happened because of the smoke coming from electric vehicle fires. If possible, if the time permits, I can actually show some videos of electric vehicle fires happening and how immense the quantity of smoke coming from the systems are. Now, these are some of the few safety concerns. So, when it comes to level 1 charging, we charge it from a 3.3 kilowatt socket. The maximum power output is 3.3 kilowatts, 16 amperes. The time taken for EV charging is more than 8 to 10 hours. People are generally unresponsive when it comes to EV chargers. The household wiring is questionable. Level 1 charging is also AC charging. Now let's see level 2 charging. This is almost similar to level 1 charging itself, but it's wired on a three-phase supply. So the starting power of level 2 charger is 7.4 kilowatt and it can go all the way up to 22 or 44 kilowatt. Generally, EV charging systems are deployed depending upon the time an electric vehicle user spends at a location. Whether it's his home, he might spend around overnight there. During that time, we need to be able to fully charge the electric vehicle. Some people prefer office charging instead of home charging. The time that they are spending in the office, they need to be able to charge the electric vehicles. So level 2 chargers are generally deployed in offices, hospitals and workplaces. When it comes to level 2 chargers, since the power is high, we'll be able to charge the battery pack much more fastly. They are also deployed in residential places, but generally with vehicles which have a long range. When it comes to level 2 chargers, we have to draw a separate supply from the mains and the charger has to be fixed. When it comes to level 1 charger, as you can see, it's a portable unit and we can carry it around. A risk that comes associated with the level 1 charging is that once we carry it around, the chances of loose connection happening is higher. So this is when it comes to level 2 charging. In the level 1 charging standards in India is actually pretty weak, but when it comes to level 2 charging, there are certain standards to be followed, especially if it comes to residual current devices that have to be used. I'll be touching upon that later in the session. Now let us check out the DC fast charging. So this is what generally people refer to as a fast charging station. So how a DC fast charging station works is that high power DC is fed directly into the battery pack. So the rectifier panels present inside this charger module, where AC to DC conversion is happening, they communicate directly with the software in the battery pack, which is known as battery management system. And using this communication protocol, current of high amperage is fed directly to the battery pack. Just to give an idea, Tata electric vehicles generally charge at around 200 to 300 amperes. The voltage is around 300 to 350 volt. But when it comes to cars like Hyundai Ioniq 5 or Porsche, the amperage is also much higher. Also, these cars charge on an 800 voltage architecture. Now, all of you might be aware, cables with this much amperage are never allowed to be close with humans. They are either passing as overhead cables or they are either passing as underground cables. But when it comes to electric vehicle charging itself, people are allowed near the charging facility. They operate using these chargers and plug it into the vehicle. There has only been one incident when it comes to electric shock happening from DC fast charging station, and that incident occurred in Kerala. We'll be visiting that incident also later on into the session. The chances of faults happening in DC fast charging is actually quite high. If the safety protocols are not properly met, there is a huge risk of electric vehicle fire happening and electrocution also happening. Generally, EV charging station equipment manufacturers equip the chargers with emergency stop buttons so that people can generally stop the charger when a risk happens. But when it comes to real life usage, what happens is that many of the electric vehicle users misuse this button to stop the charging session. And what happens is that the charging station owners inadvertently covers up this MCB switch button. Many of you might be aware of a fire button that we generally see in apartments and high-rise buildings. Now imagine what happens if we cover that button with a steel plate or with a thick ACP plate. We may not be able to access that button, right? So that is what happens in electric vehicle chargers also. There have been several cases where the MCB stop button of EV chargers have been tampered with. These are charging stations which actually also have really quite high investment. Generally for DC fast charging station, the investment goes from 10 lakhs to anyway about 1 to 2 crores, depending upon the charger size. So this is regarding the electric vehicle charging. Now let us check out the electric vehicle architecture. So what all happens in an electric vehicle? Many of you might be aware of this. Electric vehicles generally have three major components: the battery or the battery pack, the power electronic unit, and the motor. Now let's see all these three in detail. So the word high voltage, I mentioned that I've used that for a specific reason. High voltage battery stores the energy in an EV in the form of DC. Many of you might have the confusion like if my electric vehicle motor is operating at 800 voltage architecture, that means the battery pack is also operating on a similar architecture. In electric vehicles, these battery packs are mounted on floor pans and in storage compartment for scooters. But when it comes to scooters which are much more performance oriented and there is a space constraint, they are all now also started to be mounted near the footwell. That is on the floor pan itself. Now you might have like how does this concern the safety? Imagine if an electric vehicle battery pack going into a thermal runaway or a fire, and you are tasked with extricating that incident. How will you be able to put well the water pressure onto a battery pack when that battery pack is actually lying quite low to the floor? Those of you might who might have tried washing the underbody of vehicles might be aware. It is almost very difficult to get the water spray at an angle to reach the proper position inside of a vehicle. And when the hose line is charged, like firefighters use, it becomes next to impossible to attain that perfect angle. So, generally, when electric vehicle battery packs are mounted on floors, the safety aspect of it goes quite high. Also, electric vehicles become prone to flooding. Many of you might be thinking, then why are electric vehicle battery packs being mounted on the floors? The simple reason is that electric vehicle battery packs weighs a lot. Even for small battery packs, it weighs anywhere from 250 to 300 kg. High voltage battery packs of higher amperage and higher capacity, they go for more than 500 kilograms. So having this much of weight in a lower position brings down the center of gravity of the vehicle and thus improving its vehicle's ride and dynamics. Now, let us see the two common chemistries when it comes to lithium and battery packs. Now, this is actually quite important for us when it comes to safety because the nature of the battery packs, the fire risk entirely depends on what sort of lithium and battery packs we are using. So, many of you might be aware we are using lithium ion battery packs for electric vehicles as of now. So lithium is a reactive metal. Now, what is this ion that we are using? We call it as lithium ion battery pack, but the ion that is associated with it majorly improves tarnishes, improves or tarnishes the characteristics of the battery pack. So on suitable requirements, we use two general battery packs chemistries. One is NMC chemistry. It's called nickel manganese cobalt, and the other is LFP, lithium ferrophosphate. Now, the benefit of NMC chemistry is that it offers a higher energy density. But the problem is that it is relatively much more unstable than the other chemistry, which is LFP, and also the degradation curve will be a bit higher. When it comes to lithium ferrophosphate batteries, lithium iron phosphate batteries, these batteries have a relatively low energy density, but they are superiorly stable. Now, most of the advancements are happening in lithium ferrophosphate batteries. Many of you might be aware of blade cells, which are deployed by BYD. Now, these cells are based on LFP chemistry. When it comes to thermals, what happens is that NMC batteries are much more susceptible to fires. So, many of you might be having the question, then why should we actually use NMC? Can't we use LFP battery packs as they are much more safe? But the question is regarding this energy density. If you're tasked with designing a vehicle, let's say a scooter, if the battery pack weight goes up, then the scooter becomes unhandleable or unmanageable. So certain client base won't be able to use the scooters. So weight is a very big constraint when it comes to electric two-wheelers. So we have to sacrifice, or manufacturers sacrifice on energy density, manufacturers sacrifice on stability to opt for much more energy density. And also, if you are tasked with designing an electric car which has the longest range in the segment, then we have to use NMC battery packs, as these battery packs are more energy dense. So when space and weight becomes a huge constraint, NMC battery pack is deployed. Now LFP battery packs are deployed mostly in four-wheelers and electric buses. Almost all of the electric buses that are being operated in India currently run on LFP battery pack chemistry. All Tata electric vehicles that are being deployed now currently operate on LFP electric vehicles. JSW MG vehicles are operating on LFP chemistry. But long-range EVs such as Hyundai Ioniq 5, Porsche Taycan, Audi RS EQ-tron, these cars have a range of more than 500 to 600 kilometers. And they are much more performance-oriented cars, so the energy output of the battery pack also needs to be high. In those places, we use NMC battery pack. So really, it boils down to our design preferences, whether we need to opt for higher energy density, or we want to opt for higher lifespan. So that is where we use the analogy of NMC or LFP. Now I understand that it will be very difficult for you guys to remember which is NMC and which is LFP. So a common analogy that I like to use is, I compare NMC as a petrol technology. Generally, petrol engines are light when it comes to diesel vehicles, but petrol is much more fire prone. So just relate NMC technology with petrol. For two-wheelers, what do we use, diesel or petrol? We use petrol. So we compare NMC technology just with petrol, and then we can automatically make the deduction that LFP technology is used with other commercial electric vehicles and four-wheelers. When it comes to electric buses, which is the most common fuel, sorry, when it comes to just normal buses, what is the most common fuel used? Diesel. So generate diesel, or compare diesel to LFP chemistry and compare NMC to petrol chemistry. So this will be very easy for us to remember. So these are photos of electric vehicle battery packs which are used for cars and scooters respectively. When showing these photos side by side, you may not be able to detect the size and weight difference. So let us see another photo. Now you can see that the battery pack of the electric car is almost taking up the entire wheelbase of the electric car. And I have already mentioned this battery pack ranges weight ranges from anywhere from 250 kg to above 500 kg. Now that is the most important thing when I have with electric vehicle battery packs. Many people ask us, if the electric vehicle battery packs are prone to fire, can we have sort of mechanism where electric vehicle battery packs can be removed easily from cars? But the problem is, if you are handling for around 500 kg of weight on a car, where the total weight of the vehicle itself is around 1700 kilograms, then the battery pack needs to be properly secured onto the vehicle. The risk of a loose connection when it happening on physical connections, and the battery pack separating with the vehicle when the vehicle is actually in use will be catastrophic. So that is why general electric cars and electric buses have fixed battery packs. But when it comes to scooters which have range on the lower segment, their battery packs weight will be anywhere from 7 to around 18 kilograms. So they can easily be lifted by an individual user. In this photograph, you can see a gentleman lifting a battery pack out from a scooter. When it comes to safety point of view, this is a boon and a demerit also. Boon is that when electric vehicles battery pack for an electric scooter battery pack catches fire, once we extinguish the fire, there is a chance of refire or reignition happening. But when it comes to battery packs that can be removed, we can easily remove the battery pack and separate it from the vehicle, so that the rest of the vehicle and the environment can be saved. But demerit is that as people start to remove battery pack from the vehicles and charge it at other places, they may not follow safe charging practices. There's a chance of loose connection happening. There's a chance of battery pack getting damaged due to mistakes from humans. Now, this might result in an electric vehicle fire. We'll be touching on the electric vehicle fire incidents that happened in India till now. And at that time, we'll be able to understand the severity of the electric vehicle battery pack fires. Now, in all the situations where people actually died because of electric vehicle battery pack fires, removable batteries were used in these vehicles. Okay, so moving on. Now let us see the other major component, which is power electronic unit. So when it comes to electric vehicles, power electronic unit can be broadly classified into two forms. One is the power distribution unit, and the other is the battery management system. Now, the role of power distribution unit is to actually control the flow of electricity from the battery pack to the motors as we give the accelerator input. And also, as you many might be aware, electric vehicles have a feature called regenerative braking. That means when the electric vehicle is decelerating, energy, the kinetic energy of the electric vehicles is converted back to electric energy as the motor of the electric vehicle operates in the second and fourth quadrant. That means in generator mode. And the other broad classification we can have regarding power electronic unit is the battery management system. So BMS is basically the brain for the battery pack. The role of BMS is to make sure that the electricity going out of the battery pack and the electricity going into the battery pack is being kept safe so that the battery pack fire or a short circuit incident doesn't happen. Generally, many people ask me that route. My battery pack only has 30 kilowatt hour capacity. The new car has a 40 kilowatt capacity battery pack, but it looks almost the same. So, can I modify my battery pack and add a few cells into it? Absolutely not. Because once you do it, the entire BMS of the battery pack gets corrupted. This BMS of the battery pack is the sole reason that is saving a battery pack from going into fire in any of the incidents. Now, when it comes to safety, an important point I'd like to stress on when it comes to power electronic unit is that many of the cities in India experience flooding in monsoon season. In Kerala, flooding is quite rampant. In cities like Bengaluru, Hyderabad, Mumbai, during monsoon season, flooding is common. Many people have the perception that electric vehicles don't have exhaust pipes, so there is no chance of water getting into the engine and waterlogging the vehicle. That is true. However, all electric vehicles come with a water weighting capacity and the components are water resistant. But if dirty water or water gets into the battery pack or into the power electronic unit, and it starts to short some components inside the unit, then the chance of an electric vehicle fire happening is very high. Now there have been cases internationally, especially in Florida and California, where flooded electric vehicles actually went into fire because dirty water got into the battery pack or salt water got into the battery pack. It corroded the various power electronic components, shorted it, and went into the thermal runaway incident. So this is one point that every electric vehicle user and people who are planning to buy electric vehicles have to be kept in mind. We have to deal with water safely because once the water get into the power electronic components, then the reliability of the electric vehicle drastically reduces. This is a photo of a power electronic unit that is generally used in electric cars. Generally, the power electronic unit is located inside the topmost portion of the bonnet. You can see orange connectors passing onto the power electronic unit. Now, I want you to take a guess why bright orange connectors are used on. Or, so, I wanted you to take a guess why power electronic units have orange connectors. I'll be explaining that in detail later. So, motors. So, motors are one of my favorite components of electric vehicles because when it comes to safety, there is actually not much which is causing an electric motor to fail. Or when it comes to fire safety, electric motors don't go into fire in an electric vehicle. When it comes to normal domestic installation, there are safety aspects regarding it. But when it comes to electric vehicles, motors are generally far safer. If an electric vehicle catches fire, the chance of motor catching fire is generally. Also, many of you might have the perception that electric motors generally do not require gearbox. That electric vehicle motors, they generate torque right from the start. But for electric cars, a gearbox, a single speed gearbox is deployed with electric motors. It is mainly for the reason that if an incident happens on the road and the vehicle has to abruptly comes to a stop, that physical load need not be transferred straight away onto the motor. If a component needs to be veiled, the gearbox needs to be sacrificed instead of the motor. So now let us look into the fire hazard of electric vehicles. So this was like Till now, we have just brushed upon electric vehicles and the safety aspect. Now, let us look into it in detail. Now, when a public sees an electric vehicle fire, they immediately go into a panic mode. They imagine that the entire building burning down. They imagine that the fire will be very uncontrollable. But the reality is actually quite different. Electric vehicle fire can be categorized to two risk levels, low and high risk. So let us look into this in detail. So now let us look what the low risk fire is. Just like any vehicle, electric vehicle also contain objects that have a low fire risk. So imagine you are using a petrol car and electric car. These electric car also has seat cushions, interior plastic bits and rubber cladding. Imagine if a person starts to smoke inside the car and the cigarette butt actually drops onto the seat and the foam gets ignited. Won't that constitute as a fire? But how will the public see it? They will see it as an electric vehicle fire. Imagine certain sanitizers or perfumes have been used in the car and they were alcohol based and a fire incident happened. But these fires are limited to the interior of the car, although public might perceive this as electric vehicle fires. To handle these fires, we can use conventional firefighting procedures. Generally, most of the firefighting procedure personnel in India have been trained on vehicular fire. A mixture of foam and water is used, and these fires can be dosed very easily. Now, let us look at the high risk fires for electric vehicles, and let us also look what is happening, the reason for this. Now, let us say you are in the market to purchase an electric vehicle. Now, you have a choice of purchasing an electric vehicle which has, for the almost same money, you will be able to get an electric vehicle which has a 30 kilowatt hour battery, and you get another electric vehicle which has a 45 kilowatt hour battery. Generally, what will you choose? You will choose an electric vehicle which has a longer range. Now, imagine if you are gonna buy a petrol car. Now, would you even consider or would you even make this a factor? What is the volume of the petrol tank? No, right. But when it comes to electric vehicle, many people still have concerns of EV charging and range anxiety, and thus they opt for bigger battery packs. But what happens is that as the battery pack capacity increases, the number of cells in the battery pack also increases, and the chances of one cell failing and causing an entire electric vehicle battery pack fire also increases. Simply put, a 100-liter petrol tank and a 200-liter petrol tank have different safety aspects. Similarly, a 30 kilowatt hour battery pack and a 60 kilowatt hour battery pack have different risk ratings. Now, this is one risk. Now, let us see the other risk. There are high voltage cables passing throughout the car. Generally, let us see an electric vehicle, electric car. We charge using a charging port which is present in the exterior of the vehicle. This high voltage DC needs to be connected straight to the battery pack. From this battery pack, it needs to pass to the power distribution unit and then to the motors. So basically put, there are high voltage cables running throughout the length of the battery pack and the car. The chances of short circuit happening on these cables can also be not neglected. And there is a chance of fire happening from this also. Now, fires rising from electric vehicle due to high voltage cables, they have to be treated as electrical fires. So generally for electrical fires, how firefighting personnel handle is that once they reach an installation or a commercial building which has an electrical fire, the first thing that they do is that they cut off the electrical supply for it. They either cut off the supply from the discom side or they remove the fuse from the building. And then classy rated fire extinguishers are used. They are basically dry foam based and they cut off the oxygen supply. So they are called as suffocating agents. Now, when it comes to electric vehicles, so when it comes to electric vehicles, there are certain aspects that we can also follow to cut off this electric vehicle supply. On that, we'll be discussing later. Now, let us see the battery fire hazard. Many people see electric vehicle battery as a singular battery, but actually that is not the case. Electric vehicle battery packs are large lithium based batteries which consist of thousands of cells stacked in various configuration. Now, there is a very good reason why we are taking this approach of having many cells stacked in configuration rather than having a huge cell. This is done so that the manufacturing is simplified. If one cell goes weak, we can easily replace the cell, and generally the lifespan of the battery pack can be increased. Also, electric vehicle battery packs have two lives. One is the life that is when the battery pack resides inside the vehicle, and the two is the life when the battery pack is harvested out and it is used for other purposes, such as connecting to photovoltaic modules or home inverter systems. When the battery pack is made of individual multiple lithium cells, then the life to phase of the battery pack is much more apparent. Now, a certain sort of risk that is associated with this is that when a individual cell goes into fire, or a manufacturing defects happens in an individual cell, this fire will soon be spread through other cells and forming a chain reaction. So, as the number of cells in a vehicle increases, the chance of electric vehicle battery pack catching fire also increases, because the probability remain even though the probability remains the same, the number of cells are increasing. Now let us see the lithium. So as you all might know, lithium is basically an unstable metal, and lithium is very risky when it comes to catching fire. By converting it to nickel, manganese, cobalt, or ferrophosphate form by ionizing, we are making this suitable for electric vehicles. But even though when a foreign particles enters into the bare cells, there is a chance of reaction happening and the electric cell reaching temperature levels which is not meant to be. So we have to maintain the lithium ion battery pack at rated temperature also. When many people ask me buying advice on electric vehicles, when it comes to electric cars, I always prefer electric cars which have an active cooling system inbuilt to them. Generally in India, we have very harsh summers, and we don't have that much of harsh winters. So what happens is that during summer season, when a person is driving an electric vehicle on the highway, his battery pack is already put on load. Then there is the added heat of electric vehicle reaching higher temperatures because of hot sun. And this electric vehicle user goes to a charging station and plugs it to a DC fast charger, the load on the battery pack actually increases. If the battery pack doesn't have an active cooling system which is able to maintain the battery pack at the rated temperature, there is chance of fault happening. But many manufacturers opt techniques to make the battery pack safe by cutting off the power when the battery pack reaches above a certain temperature. Now let us look at thermal runaway. So thermal runaway is the technical process that happens when an electric vehicle battery pack goes into an uncontrollable fires. So let us see how this process works. So failure in lithium batteries can sometimes lead to excessive buildup of heat inside a cell. So I want you all to imagine a cylindrical lithium ion cell. Due to some reason, whether it's user induced or a manufacturing defect, this lithium ion cell fails. When this lithium cell fails, the lithium cell temperature increases, the liquids or the paste inside the battery cell actually reaches a higher pressure. It forms into gaseous states, and it puts pressure on the lithium ion cell walls. Eventually, the walls of the lithium cell ruptures, and hazardous inflammable gases of high temperature released gets released into the environment. That is the environment inside the battery pack itself. Now, there will be at least four cells surrounding a single cell in a battery pack. Due to the inborn heat from the original faulty cell, the other cells will also take up this heat and follow suit into a same manner. That means one cell catches fire and hot gases gets released into the environment inside the battery pack. This hot gases induce fire for the other cells. So one cell becomes to 4, 4 becomes to 16, and then to 64, and thus a chain reaction forms. Generally, for when we are able to judge when the electric vehicle is going to fire, how much time we have to respond, there is a technique which I used to call as white smoke technique. So, if the electric vehicle fire starting to go up, and the smoke coming from the electric vehicle battery pack is actually very light, it's white, then we have time to react. If there are trapped persons inside the car, we have time to rescue them. But if the color is deepened already, then there is a high chance of vehicle going to battery pack sooner. When it comes to electric cars which are on the LFP chemistry, this risk is actually quite low and the time limit is higher, so that we have much more time to react. The ignited battery pack can't be suppressed by using conventional firefighting methods, because when we use foam-based fire extinguishers on this, it only cuts off the oxygen supply to the secondary fires which are formed outside the vehicle. The root cause of the fire is the hot gases that thermal runaway cause which are present inside the battery pack. Once the fire extinguishing foam dries out and the hot gases gets released later, the fire actually continues. Now, this is a photo of an electric vehicle which caught fire. Now, the thing is that this is a photo of a reignited fire when the vehicle reignited on the second day. That means this is a photo that we took, or that not me, that the photo of the electric vehicle that have been took once the fire has been for more than 24 hours. There is a high chance of reignition when it comes to electric vehicle fires. So generally, EV mature markets such as US and in European countries, they call electric vehicle hellfires because it is very hard to extinguish, takes a lot of manpower and resources. Now, there is something that I wanted to introduce to you about known as phase changing materials. So, when I'm taking the program for electric vehicle fires in Kerala, back in around 2022, the number of electric vehicle fires happening per month was around 1 or 2 only. Now it's well over 10 incidents. But there are cases where it's not the battery pack of the vehicle that went into fire, it's the power electronic module or the charging module. Even though the entire electric vehicle went into fire, the battery pack actually remained safe. The major reason for this is something known as phase changing materials. So phase changing materials are generally heat absorbent materials that we incorporate into the battery pack. What this does is that it essentially slows down the chain reaction of one cell passing on the fire to another cell. How do we explain this very lightly? Imagine you have a lot of firecrackers at your home, and these are fresh ones, so they'll be much more easily able to catch fire. But say, imagine you soak these firecrackers in water and they become damp. So even though you ignite a portion of the firecrackers, the chance of fire spreading to the other crackers will be very low. Similarly, there what is happening? Water is absorbing the heat. Here, certain chemical materials are incorporated in the battery pack so that the buildup of heat is absorbed by these phase changing materials. There was an incident of an Ola electric vehicle fire where the charging unit caused the fire. The entire electric vehicle went into fire in Tirunelveli district. However, the battery pack didn't catch fire because they had much more better phase changing materials. Now let us see safety precautions and measures. So this is one of the important topics in this session. So once we follow this, the risk that is associated with electric vehicles actually comes very low. And there is one point in here that we use. Even if we follow just a single point, the electric vehicle death toll that would have happened would be very low. So when installing home charging, we have to inspect the household wiring, whether the amperage or the wirings is rated for that much amperage, whether there is short circuit. And also there are tendencies where electric vehicle people use electric vehicle supply equipment which are of very shoddy manufacturers. Now what happens is that manufacturers, they skimp out on the standards, they skimp out on RCDs, they skimp out on various safety components to reduce the cost, and the public buys these electric vehicle chargers and end up burning the entire vehicle. This phenomenon has been much more observed in electric three-wheelers and two-wheelers. When we are charging electric vehicles, we should check the charging guns for damage or loose connection. And also, the most important point, avoid charging removable batteries near flammable substances or in closed spaces. Now, if this was followed religiously in India, I can guarantee that the death toll when it comes to electric vehicle fires will be turned to zero. Currently, the death toll regarding electric vehicle fires is around 20. In all of those incidents, electric vehicles or the removable battery from electric vehicles have been charged in closed spaces without proper ventilation. I will show you a couple of examples also onto this. Also, when we are charging generally, even though chargers are safe, IP67 rated, IP54 rated, many people practice charging in heavy rain also. So even though the charger is IP rated, the person doing the charging session, his body will be wet. That means his resistance will be low and there is a high chance of electrocution happening. Many people residing in apartments use extension cables. Even though there is a practical requirement to use extension cables, as per all standards, we shouldn't actually use extension cables to charge the electric vehicles. But if we are having to use the extension cables, we have to make sure that it's of proper current rating. Generally, we have to check for installation failures also. Like I mentioned, DC fast chargers have the MCB switch in an accessible position. So this MCB switch is to for a third party respondent to trip the switch when an electrocution happens or electric fire happens. But many charging point vendors cover the switch with a thick material, making it difficult to access. Also, when it comes to using electric cars, avoid parking electric vehicles in direct sunlight. Now, what happens is that any vehicle that is being parked in direct sunlight, the temperature inside the cabin rises to around 80 degrees in summer when it comes to noontime. What happens is that this imposes a certain load on battery packs. Generally, most of the manufacturers make sure that the battery pack is sound for 1 or 2 faults. But imagine if a battery pack already had a manufacturing defect or already had a user induced defect. And on top of that, you are exposing it to direct sun. There is a high chance of electric vehicle going into fire. And also, people who are using electric vehicles are very rigid on their charging times. They need to charge the electric vehicle as fast as possible and they need to continue to the journey. But when the electric vehicle is being used on highways and that too on a sunny day, the load will be very high. If you don't wait for some minutes for the electric vehicle to charge, there's a chance of electric vehicle being pushed to certain limits. In Tamil Nadu areas, I have seen various cases where there are charging stations in the open, but they don't have proper coverage. So electric vehicles, when they are being charged from there, the temperature in the electric vehicles actually reaches unrecommendable limits. Also, when it comes to handling electric vehicle battery packs, especially the removable battery packs, we have to be careful not to dent or damage the battery packs. Generally, what happens is that if a battery pack appears to be damaged, people plug the battery pack in and they check the LED status whether it's working or not. But if there is a damage that happened to a cell, the precautions of that will be seen later, not at the day we are using. And I already mentioned on using electric vehicles on waterlogged roads. Even though there is no exhaust system in electric vehicle, if the water reaches power electronic components and electric wires, there's a chance of electric fire happening. So avoid modifying the battery in any cost. When we are adding more cells to enhance the battery pack capacity, we are essentially ruining the BMS. The one job of BMS is to manage the safe charging and discharging. Without a proper BMS, the battery pack can actually function as a bomb itself. That's unsafe. Also, if an electric vehicle crash occurs, always inspect the battery by a professional. All OEMs who manufacture electric vehicles do this, but once the electric vehicles are past their warranty policy and people start third-party repairs, that is when these issues come into picture. Now, EV extrication is how we can actually remove passengers who are trapped in electric vehicles. Generally, to do this, there are certain components inside the electric vehicles that we can access to make sure that the external panel of the electric vehicle is kept safe. One component is called high voltage cutoff. So HV cutoff in an electric vehicle, this is how it looks like. It's a small tab in the bonnet section. If we pull it, the high voltage cables supply is actually went out. The electric vehicle battery packs cuts off from the major supply and the wires are de-energized. So the chance of short circuit happening is very low. Now there is a question that might happen if an electric vehicle crashes and the bonnet is collapsible, then what do we do? Then there are other points for the electric vehicle, so such cutoff known as battery isolator. So generally, when we remove the battery isolator, the electric vehicle battery pack and the high voltage wiring harness is essentially separated electrically. This is generally located on the bottom side for electric vehicles. Now, here you can see the battery isolator, the wires, and the other wires in the electric vehicles are in bright orange. The reason for this is that if an electric vehicle fire or a shock situation happens, and first responders are not able to access this properly, or there are difficulty seeing this, if there are smoke or there is a night time, these wires are made orange so that they are made visible even in low visibility situations. So it's a standard that is followed by all manufacturers, whether it's a lower end segment Tiago EV or it's a higher end segment Mercedes EV. All electric vehicle high voltage wires are made bright orange. So if you see an electric vehicle wire hanging loose from a vehicle and it's in orange color, you can see that it's a high voltage cable that is hanging out. So generally, electric vehicle battery pack fires can be assessed using thermal imaging cameras. Many of the firefighting departments in India don't possess the thermal imaging cameras. So they use the quadrant method to find out the electric vehicle battery pack fire, whether it's happening from the front or back or the left or right, and they'll be able to isolate the hottest point in the fire. Also, when it comes to firefighters rescuing electric vehicles passengers, generally they have to be ready with firefighting equipment so that even when the passenger is being rescued out, fire can happen. Now, there are some challenges due to battery pack placement, which I explained earlier. If the battery pack is mounted low, then the accessibility to the battery pack is very low. In mature markets, this is how a battery pack looks like. In mature markets, special struts are used to access the electric vehicle. If the battery pack is experiencing fire, they first spray it with foam and water. First, the initial fire has been ousted out. They then raise the battery pack to an angle and access it. In India and generally in Kerala, what they do is that they use standard jacks to create an angle for the battery pack and flow so that water can easily be passed upon. So general precautions while accessing the batteries, no holes or anything should be made, and the battery pack shouldn't be damaged when we are accessing it. Now this is the important topic of fire suppression. Now I'll give you guys a very simple example. Let us consider you have two containers. One is a glass container which is having hot water. The other is a thermo flask which is containing hot water. You are 5 meters away from this setup and you have a cold water hose in your hand. You are tasked with bringing down the temperature inside these containers to normal levels. In the glass container, you will be easily be able to do this, but in a thermo flask, even if you spray water onto the outer surface, it is very difficult to get that water temperature inside the thermostat to a lower limit. Now, exactly this is what is happening in the battery packs. In most of the vehicles, battery packs are made fire resistant, and they are made for two reasons. If there is a thermal runaway incident inside the battery pack, the goal is to protect the occupants inside the battery pack, and also if a fire happens outside of the vehicle or for any other component of the vehicle, this fire shouldn't actually interfere with the battery pack and make the battery pack go into thermal runaway. Now, a problem is that once the battery pack actually goes up into flames, it is quite difficult to extinguish it. Essentially, we are trying to reduce the temperature of a water kept inside a thermo flask by spraying cold water onto the external body of the thermo flask. So there are certain measures that firefighting people actually use for this. Now, a major problem is that since the battery pack is made up of chemicals, we can't treat this as a regular vehicle fire nor as an electric fire. And the gases being produced inside the battery pack for due to thermal runaway, these gases come out again and they start to reignite the fire. So, how the electric vehicle fires are let out is that after the first secondary fires are put out by using foam or water, and once that is put out, huge quantity of water is actually pumped onto the battery pack, or a bund is constructed around the battery pack area of the electric vehicle and it is filled with water. So what we are doing is that we are constantly keeping pumping on electric vehicle with water in attempt to reduce the battery pack temperature. This can range from anywhere from 10,000 liters and much higher in the case of electric buses. A general capacity for an fire truck in India is around 4,500 liters water capacity. That means just to douse an electric car fire, we need at least two fire trucks. Modern day electric buses actually come with nitrogen tank infitted inside the battery pack with smoke detectors. When a smoke is detected inside the battery pack, nitrogen is released at high pressure, thus cooling the battery pack in an attempt to reduce the temperature. Now, while accessing the fire, also if the battery pack is actually tilt and we have position to access the fire, we'll be able to access the battery pack in a much more efficient way by focusing area to the point where heat is actually coming out. No additional cracks need to be used for this. Generally, what happens is that for removable batteries, generally for scooters, once you douse the initial fire, it is much more recommended to remove the battery pack and place it into a large container containing water so that the excess buildup of heat is doused by the water itself. Now, EV mature markets have specific instrumentation to use for this itself. So this is a sort of crane sort of equipment where it's an hybrid car that is being used here. As an example, an electric vehicle can be doused into a tank so that the battery pack will not reignite again. And there are certain equipments like what Rosenberg developed. Basically, instead of spraying the entire battery pack with water, a certain equipment is placed underneath the battery pack. It's a computerized equipment. The vehicle model is imported into it. This computer actually scans the battery pack, finds out the hollow spot, pierces a lancer into it, and pumps the battery pack with water, effectively cooling the insides of the battery pack so that the battery pack can be cooled without that much wastage. So this is how a battery pack fire is doused. Now let us check out a few fire incidents that happened in India. So first is the Vellore EV fire. This is the first recorded electric vehicle fire death that happened in India. I think remember if I remember right, this was back in 2022. What happened was that a father and a daughter were inside their home in Vellore. They charged the electric vehicle in the port sector. The charging was happening overnight. The electric vehicle used here didn't have this particular manufacturer has been blacklisted by ARI now. At that time, there were no safety standards. The battery pack went into fire and a huge quantity of smoke started popping out. And also, when a battery pack fire happens, when each individual lithium cell bursts, it has a firecracker like sound. The father and the daughter panicked and they went and hid inside the bathroom. The entire house was covered in smoke and they died due to asphyxiation. They didn't die due to the fire, they died due to the smoke which surrounded the house. This is the first recorded death related to electric vehicle fire. Here also, it's not the fire that you use caused. Here is the electric vehicle fire smoke that caused the death. Here also, they charged the battery pack in a summer inside a porch where there wasn't proper ventilation. The most horrific electric vehicle fire incident is Sikandrabad EV fire. The manufacturer of an electric vehicle name is also mentioned here. So what happened in this incident was that in ground floor and in the basement, it is an electric vehicle dealership. In first floor and in second floor, it is a lodge that was functioning. The dealership generally has a lot of rush. During night time, they cut off all the ventilation to the dealership. They shut off all the windows. They put the shutters down and they put the electric vehicles for charging. Due to some incident, the electric vehicles actually, one of the electric vehicle went into fire. Now this started a chain reaction and all the vehicles in the basement started to go into fire. Since the basement didn't have proper ventilation, the smoke started rising into the building. And 8 people inside the building had to succumb to this. 8 people. 22 people were injured. Among that, 8 people died. This was because the smoke didn't have anywhere to go through and it engulfed the entire building, trapping the people inside it. Other is an incident of an Exxon EV fire. Actually, this was what I know personally know the owner of this electric vehicle itself when this incident happened. So this was a clear case of manufacturing defect. The electric vehicle actually went into fire, showed indications that there is a thermal runaway incident about to happen, and user got an intimation to pull over the vehicle. He pulled over the vehicle, informed the authorities. However, when the authorities reached, this happened in Mumbai. At that time, there was no information on how to douse the electric vehicle battery pack fire, and they basically opened the bonnet and the doors for the electric vehicle in hopes to reduce the incident. But if they had tilted the battery pack or anything, they could have easily doused this. It took about 6 hours to douse this battery pack fire, and this was the first case of electric car fire happening in India. These are some of the common electric vehicle fires that happened. Now, also there are few standards when it comes to EV and electric vehicle charging, but there are no standards when it comes to electric vehicle battery pack going to fire or thermal runaway that is happening. So IS 18590 and IS 18606, these standards generally deal with the critical components of electric vehicles and the safety. However, there is no mention in these standards regarding how an electric vehicle battery pack fire should be suppressed and what all measures has to be inside the battery pack to make sure that the battery pack fire is easily attendable. The other standards, automotive industry standard 138 part 1 and part 2. Part 1 is for AC charging systems and part 2 is for DC charging systems. These are ARI standards. The latter two are for EV charging and the former two are for electric vehicles. Now, our major role when it comes to this is that after the session, you might feel that electric vehicles are actually quite risky, but the reality is quite the opposite. if we use electric vehicles in a proper manner, the chance of fire happening is very low. And I already mentioned that we could have reduced the death toll of electric vehicle fires to zero if we just followed one point: avoid charging batteries in closed spaces or remove without proper ventilation. Now, in the upcoming National Building Code, currently it is in draft stage, they have specifically mentioned EV charging points in high rise buildings and apartments shall not be allowed if there is no proper ventilation. Also, now I advise multiple RWs and apartment associations to restrict electric vehicle users from having removable battery packs which are allowed to be carried into apartment buildings. Because if the removable battery pack goes into fire inside of an apartment, there is not much we can do about it. So charging measures or charging provisions need to be allocated in common area amenities, making sure that these places are well ventilated. When it comes to electric vehicles, even though this fire happens, this fire is not rapid when it comes as in petrol fires. Many of you might be aware petrol fires happen instantly in petrol cars, but in electric cars, the electric vehicle actually supply cuts off, and then the electric vehicle eventually goes into fire incident. But when it comes to petrol vehicles, this is not the case. So if you actually plan to use the electric vehicle in a proper safe format, the result we can yield from electric vehicles is actually very much higher when it comes to petrol vehicles. We are reducing pollution and we are generating the overall safety also. But users are considering electric vehicles as normal vehicles itself. No individual will pass near a 200 ampere cable. But when it comes to EV charging, he is casually holding onto the cable even though he is soaking wet. So these are the situations that happen when it comes to electric vehicle safety. So if we actually educate the customers and the public on electric vehicle charging and electric vehicle safety measures to be followed out, we'll have a much more better impact on creating a much more safer environment for electric vehicles. So now we can have a doubt clearing session.
Yes, thank you very much, Mr. Govind. It was a very nice session, interesting session. We have a few questions on the Q&A. Probably you also can see those questions. And for
Definitely.
you, I will read. The first one is from Mr. George Matthew. What are the measures, Mr. Govind? Probably if you switch on the
I am trying
video,
to, yeah,
video.
just a second. So I'm, there are multiple messages in the chat. It will be
Don't
helpful
look
if the timeline can
don't
be.
don't look at the chat. Don't look at the chat. Near to the chat, there is Q and A.
Okay.
You have to look at Q and A, and you can also switch on the
Yeah,
video.
my video sound.
Yeah. You see, can you read the first question? This is from Mr. George Matthew. What
Yeah.
are the methods available in
Electric
electric vehicles to detect off gas, thus by avoiding battery thermal runaway and fire?
I don't see that. Uh, there was electric mobility, viability, efficiency of power plant, transmission distribution losses, plus
At the, no,
efficiency of
at the
electric.
top. At
Okay,
the
okay.
top. You look at the
Okay.
top.
When lithium ion battery reaches to thermal runaway, nobody can save the battery. Actually, we are able to save the battery. In Kerala
I
itself,
think you are
there
still
are,
reading. I think you are still reading the questions from the chat box. Please don't look at the chat box.
yeah, it's a Q&A section, open 12.
Yeah. Yeah.
Is a,
Open.
yeah, Gopal
No.
Yadav had asked, is electric
Open
vehicle
8.
more efficient?
Open
Pardon?
8. Open is 8, not 12.
Okay. So is vehicle more sufficient efficient in comparison with fossil fuel? Yeah, like I explained in the session, the electric vehicle drivetrain has an overall real world efficiency of 80 to 95 percentage itself. But no petrol vehicle can have efficiency of more than 50 percentage. Currently, Mercedes uses a petrol engine which has a thermal efficiency of 50 percentage, but that is being deployed in Formula One. When it comes to internal combustion engines which are being used on on-road cycles, the efficiency is actually 35 percentage. So there is a significant gap in terms of efficiency when we are comparing fossil and electric vehicles.
Okay.
Also,
So
Mr.
Someone
Yeah,
is
Larry.
asking for the presentation. We have a policy. We will not be sharing any of the presentation slides because these are the proprietary property of the person who is making the presentation. So,
Uh,
whereas we will be uploading the videos in the YouTube, you will be able to get all the information from the YouTube video. Please look at the YouTube channel of NFE. Uh, uh,
so,
so I
what
don't
is the
know
most
whether
common cause of
uh,
fire
I don't know
regards
whether
to?
you are able to open up the Q&A.
Yeah, Q&A session. Yeah, I'm able to access it. It
Yeah.
shows
Now
14 right now.
14. Okay. I don't know. I'm seeing only 10.
Okay. So
Yeah.
Mr. Larry had asked, what is the most common cause of fire with regards to electric vehicle? There are several cases. Up till around 2023, it was manufacturing defects, but afterwards, user negligence. But in most of the cases, it is not one reason which pushes the electric vehicle to a fire. It is more than one reason. Let's say an example: your electric vehicle has a manufacturing defect, and there is a foreign material inside the battery pack. Now you don't practice safe charging measures and you end up overcharging the battery pack or pushing the battery pack to the limits. Now, both these reasons combined might cause an electric vehicle fire to happen. So, just to be on the safer side, if you follow safe charging and safe EV usage measures, the chances of fires happening will be very low. Mr. George has asked, what are the measures available in electric vehicles to detect off gas, thus by avoiding thermal runaway and fire? Currently, all electric cars which are being sold in India will be equipped with smoke detectors. The smoke detectors, once they go off, they will send a UI message onto the instrument cluster of the electric vehicle, and the power supply will be cut off. But unfortunately, for a smoke to be detected, the battery pack will have already started thermal runaway. Once a battery pack started thermal runaway without external measures, we won't be able to control it. Mr.
Okay.
Gopal has asked,
So from Mr.
recently
Gopal
we
Yadav, right? The next question.
Recently, we have got news global temperature increased to 1.05 degree temperature parameters, more concern for electric vehicles. So, is it safe to use in the future? Actually, this is a very good question. In the presentation, also, I forgot to mention many people associate the battery pack as the temperature limiting component. Actually, that is not the case. Battery packs for electric vehicles they can actually withstand higher temperature, but it's the power electronic components which actually go into failure. Just to put an example, electric vehicle battery packs they can sustain temperature for more than 300 degrees Celsius. But for the power electronic unit, it cuts off the supply when the temperature goes above 80 degrees Celsius in most of the electric vehicles. So global and temperature increase and electric vehicle battery usage, it doesn't have that much an effect. Most of the electric four wheelers already come with battery cooling systems. Does overcharging the battery to short, Mr. Larry has asked, does overcharging the battery to shorten the life of battery? What is the average life of electric battery? For NMC based battery, the lifespan is around 2000 cycles. For LFE based batteries, it varies depending upon the charging power and the energy output. So basically, heat is the component that is the deterrent factor here. If a battery pack is charged at a slower power, and if the vehicle also is not used rigorously, then the power output of the battery pack will be lower. That means the heat generated in the battery pack will be lower. Thus, the life will be higher. For electric cars, like most of the cars that are being sold have more than 1.5 lakh kilometer warranty. When we consider the battery packs to be deployed in cars up till 70% of health, we can easily get anywhere from 2.5 to 3 lakh kilometer. For scooters, it's generally around 1 to 1.5 lakh kilometers.
Okay, thank you.
George
Thank
Matthew.
you, Govind. The next question is from Mr. George Matthew. My experience with lithium ion is very bad. Personally experienced many battery fire incident. All the questions are from experience. Can we share, we can share and explore the possibilities to make our environment. Okay, it's not a question, it's a statement, but let's go to the
Okay.
next question. During the thermal runway of battery, which of the gases expected to release? From Mr. Mohan and
Carbon.
K.
Now, this depends on the phase changing materials used inside the battery pack and the iron of the battery pack. There are hydrogen sulfur gases that sometimes emit, and in most cases, it's the carbon monoxide itself which causes the fatalities.
Yes. Again, from Mr. George. Probably this is this is not a question; it's a statement. Mr. George says in data centers we use VSDA and early gas detection system and water mist to reduce the possibility of battery fire. However, the confidence of fire suppression is low. It's not a question;
Uh,
it's a statement.
Right, but
From
I'll
Mr.
just clarify something regarding that. When it comes to electric buses, the battery pack capacity is very high. Now, most of the modern day buses that being sold, they come with nitrogen tanks attached to it. So once the smoke is detected, nitrogen is released at a pressure. As you might know, as volume increases, temperature reduces up for a gas, and thus cooling the battery pack. Now, what this allows is much more time for the passengers to get out of the vehicle and the battery pack also to be controlled. Okay.
Okay, that's good answer. Yeah, from Mr. Vinod B. What are all the safety precautions needed to be taken for EV vehicle taken for long trips? Please share your comments.
So, like I mentioned in the presentation itself, when we are driving electric vehicles for long trips, first of all, we need to understand that EV charging infra is still not 100%. So, a certain risk need to be associated with this. When we are doing fast charging, we need to make sure that we are doing fast charging at a safe location where there is a roof or canopy at the charging station, and also the electric vehicle battery pack health is very good. In most of the cars, they come with connected systems using which we can do a remote diagnostics of the electric vehicle, thus making sure that the components of the electric vehicle are fine. When it comes to normal petrol vehicles, we have to top up the coolants, worry about the radiator water levels and everything. That is fine with electric vehicles, no need. But however, we need to do a remote diagnosis on battery health. Apart from that, there is nothing to be concerned about long-term usage or long trips.
Okay, now a question from Mr. Gogul Das. What are the safety measures to be taken while setting up a charging station?
Yeah, very good question. So, yeah, there are two standards regarding this: AIS 138 Part 1 and AIS 138 Part 2. In many of the cases, which I've seen, is that the RCDs are being used of the wrong rating. And in electric vehicle, ultimately AC is converted to DC. Now, there is a chance of DC leakage happening. What will happen a DC leakage when it happens into a Type AC RCD? The RCD will get stunned and tripping won't happen. So we need to, as per AIS 138 Part 1 standard, the RCD to be used in EV charging station shall be Type A or above. That means Type A or Type B. But many people put general RCDs of Type AC rating. Also, in a charging station, it should be well ventilated. There should be ample parking space, and also the MCB switch needs to be located in a accessible position. Now, even though there is an AI standard on it, that has not been mandated by licensees and inspectors in various states. But once this has been mandated, the safety of charging station actually goes up. There has been one incident where an electric car BYD Atto 3 went into the connector went into fire when charging at a charging station in Tamil Nadu. Now, what BYD concluded was that the connector of the charging station had a loose connection and it caused the fire on connector side.
Okay. Okay, so basically, the use of RCD, for example, type A and above is preferably type B is what is recommended, but
Type A is
unfortunately,
preferred,
using
but now the problem with Type A is that in Type A, old DC leakage only up to 6 milliampere is rectified, or
yeah,
it works on. But the issue is that in the AS188 standard, it says we have to use a Type A RCD, and we have to make sure that the electric vehicles DC leakage is less than 6 milliampere. Now that is not something we can predict upon. If the electric vehicle becomes faulty, the DC leakage might be higher. So this is
exactly.
like yeah, this is like saying if a vehicle crashes, only one component of the vehicle is safe. While crashing, you need to hit that portion of the vehicle. So
Yeah.
ideally, Type B should have been mentioned in the standard.
Yeah, yeah. So type B is the best. The best is to go for
Yes,
type B RCD in such case. But the problem, availability. I think
availability.
most of the manufacturers in India are not supplying type B RCD, and even if they do, it's at an exorbitant cost. Okay, the
Yes,
next question.
earlier Tata supplied their portable chargers with Type B RCD. Later on their new vehicles, they changed the RCD to Type A.
Okay. So the Narayan is asking, will sodium ion batteries be used in EV batteries, used as EV
Definitely.
battery?
Definitely, BYD is currently researching on it. There are a couple of cars being sold in China. In 2026, we'll have sodium-ion based electric vehicles being sold in India.
Oh,
BYD Seagull, that's the car that's being sold in China with sodium-ion battery.
okay, the next question is from Mr. Vinod. What are the measures needed to be taken for increasing the battery life of EV vehicle?
Reduce as much heat as possible. Avoid unnecessarily DC fast charging. Avoid overcharging. Do AC slow charging to the most. Make sure the cells are balanced properly. And while using the vehicle, avoid unnecessarily accelerating and putting load onto the battery pack.
Okay. So also Mr. Vinod is asking, please throw some light on safety of hybrid cars with petrol and electric option. What are all the precaution measures needed to be taken for such type of vehicle?
Now, I actually in US there was a study recently regarding safety of vehicles. Now, hybrid cars rank the worst because hybrid cars generally have a smaller battery pack and they are much more energy dense. But there are all the risks associated with the ICE vehicles in this. Now, what happens is that the risk associated with the ICE vehicles of going into fire and a battery pack being attached near the engine. Now, this is not a very good combination to have. Hybrid is basically just a transition period from petrol vehicles to battery electric vehicles. It's just a matter of time they'll be ruled out from the market.
Okay, right. Thank you. Then there is a question from Mr. Anush. Will the chance of fire increase if the state of health of battery comes below a certain limit? That means
No,
probably
no.
if it degrades
The
to
chance of fire of an electric vehicle depends upon the heat generated and the chemical nature. The state of health or state of charge doesn't have any impact on it.
Okay. So a question from Mr. Balachandran. Can we install electric vehicle charging station in basements? Do we need feasibility approval from the Central Electricity Authority?
In the CEA standards, it's not mentioned, but in the upcoming NBC draft, it's mentioned up to level 1 basement provided there is proper ventilation.
Okay. So which part of the NBC draft you are referring?
That draft I was not sure of. I'll get back to that on that later.
Okay. What about the automotive standard the published by the government of
Yeah.
India says?
In that standard, there is no mention regarding charging in apartment. Only in the National Building Code draft, it's been mentioned charging points can't be installed in places where there is no ventilation.
Okay. Okay, it makes sense. It's a sensible
Yes.
subject. Okay. Is it dangerous to ride? Okay, now Govind, in that particular case, what is your personal opinion in that subject? Where to locate the charging station? Of course, ventilation is a big subject. Next,
Hmm.
apart from that,
No, in apartments, in most of the apartments, when it comes to tier one cities, parking will be an issue. The general approach I give is that now, as per Kerala Electricity Supply Act, now in the case of CA, I was not sure, but for existing apartments, individual charging points shall not be allowed because once everyone starts asking for individual charging point, the capacity of the transformer needs to be upgraded. Only common charging points shall be installed, but they need to be installed in places that are very accessible, have proper ventilation, and have weather protection also. Generally, level 1 basements near to the entrance where there is very good ventilation, or on the common parking or guest parking,
preferably outside. Yeah, that is what
preferably
is.
outside.
Yeah,
But protected from weather.
yeah. Okay, now there is a question from Mr. Pradeep. Is it dangerous to ride a EV kept in open when the ambient temperature is high?
There are safety measures in every electric vehicles to make sure that if the battery pack overheats, the power is reduced. However, if that thing fails, then there is a huge risk. A general practice should be, unless it's an emergency, don't keep the electric vehicle parked in a hot environment. But when the electric vehicle is being used, the battery pack cooling is being functioned, and there is not much of a risk.
Okay, so there is a question. That's a good answer. Now there is a question from Mr. Okay, from an anonymous attendee, is the standard for firefighting water quantity requirement for multiple EV car charging bike? Is there any standard?
No, absolutely no standard. I had cross-checked this with multiple firefighting departments internationally. There are only practical use cases that has been developed. For lithium-ion cell fires, there are multiple standards. But when it comes to the lithium-ion cells packed in a pack and kept inside a fire-resistant material, there is no standard as of now.
Okay. Right. Again, from Mr. Vinod, during the travel, how can we ensure the safety of private power charging source? Please share your
Uh,
suggestion.
by private power charging source, I'm not sure what is meant on that.
You see, he's traveling and there are charging stations on the roadside. Is it safe to charge from those stations?
Yeah, generally what I recommend people to look out for who is manufacturing that machine. Generally, people cover the machines with a lot of stickers and everything, but on the side of the machine, we can find the spec plate. When it comes to a shoddy manufacturer, which we are not actually aware of, it's much more recommendable to skip the chargers. Also, if there are any charging station operators in this presentation, I would encourage everyone to opt for charging stations which are relevant with certain standards, with the A standards at least. In many states, these standards are not kept as a mandate. It's kept as an option itself.
Yeah, but there is already IS standard, I think, 17
Yeah.
something like that. There was
In Kerala,
legislation.
more than 50% of the charging stations are not up to that standard. The almost 75% of the KCB owned charging stations are not up to that standard. They were before that standard itself.
So how many percentage you told? 50 percentage in the general case and
More than
KSEB?
50% of the KCB owned chargers are on the older technology and they are not as per the standard. There has been
Okay.
a specific incident in Kerala when a lady got electrocuted while DC charging. She placed the charging gun from the vehicle to the receptacle and she got electrocuted. What happened was that this charging station was located right next to a KCB substation. Now, before she was plugging the gun back into the charger, an earth fault happened in the substation and current passed to the ground. Now, while she was putting the gun back to the charger module, using her thumb, she held the holder for the charging gun receptacle, which was a metal part and it wasn't properly insulated. Her left knee had touched the barricade which prevented the car from hitting the charging station. Now, that barricade was an unearthed body. So, current passed from that unearthed body into her body and she was electrocuted. Fortunately, she was safe.
Okay.
Actually, we should file an RTA on this to find out the reportings of the KCB on this matter.
Anyway, we have to be happy that at least 40 percentage are in good condition. So there are
So,
standards like the IS published a few standards on this particular subject. The series of standards are basically IS 17017 series of standards, which talks
yes.
about, for example, electric vehicle conductive charging station. Multiple
And
standards are there.
standards are mainly about the installation and operation of electric vehicles. I am aware of the standard. In that standard is mentioned the electric vehicle charging station has to be tested every 6 months. In this
Hmm.
particular case of electrocution, people pointed out that the electric vehicle charging station had cobwebs on the charger gun itself, showing that this charger was not maintained properly. Additionally, the licensee in Kerala was not able to produce any records which showed preventive maintenance being done on the charger.
Okay, so that means the whatever recommended in the regulation and code of practices is example the National Building Code has got a provision already, so that is not maintained. So basically, Section 146 of the Electricity Act can be applied. The responsible person can be put in jail for 3 months. The responsible
Yes.
person, either the charging station owner or whoever. Okay, anyway, that's not our subject now. Mr. Amritlal is asking a question whether EV charging testing and commissioning standards are covered in 17017.
There is a Ministry of Power guideline dated September 2024, guideline for installation and operation of EV charging. In that, this is mentioned, and also in the CEA recent guidelines I had seen regarding the standard. But regarding the standard, I haven't inquired that much.
Okay, now, right. So we will, probably we have to continue this program maybe once again after a few months with more updated information about these standards.
Yeah.
So Mr. Muralidhara is asking, can a two-wheeler EV be charged from in light circuit, the lighting circuit from houses?
Yes, I mean, there are many cases where people assume electric vehicle charging to be inductive loads. Actually, that is not the case. Electric vehicle charging, we have to consider it as a lighting load itself, but of higher power. When using the MCB, we have to use type B MCB, not type C.
Yeah, type B MCB is
Type
what
B.
is referred. Okay. So the next question, Mr. Shailendra Rana is asking, F500 BIS, probably you can also read. I think there is some spelling mistake.
BS noted as the right fire extinguishing agent. Your take on this? Use of water on lithium batteries. Actually, I'll explain on this. Now, it's not the use of water that propagates fire. It's the use of salty water or dirty water. That is what causes ionized fire. In the Mumbai Fire Department itself, there was a discussion on this whether what material needs to be used. Water is used for electric vehicle fires not as a suppressing agent. It is used as a cooling agent to bring down the temperature of the battery packs to acceptable levels. Conventional firefighting agents, like you mentioned, they act as suffocating agents. On regular electric fires, it is fine. Conventional suffocating agents cuts off the supply of oxygen and the fire stops. But when it comes to EVs, the supply is cut off and the fire stops. However, the hot gases trapped inside the battery pack still keep coming out, and these hot gases cause reignition. To reduce this reignition, the only possible methodology that we have is to reduce the battery pack temperature. Since the commonly available coolant being water, we spray the coolant onto an electrically insulated battery pack itself. So the chance of voltage leakage happening is very low.
Okay, right. So, what is the, Mr. Smita is asking, what is the difference between AC? I think there is a spelling mistake, charging and DC charging.
I lost track
Fast
of the,
charging.
the AC fast charging, DC fast charging. So whether it's AC fast charging or DC fast charging, in AC fast charging, inside the vehicle, there will be a component called as onboard charger. This onboard charger converts AC into DC and it's fed into the battery pack. When it comes to DC fast charger, this onboard charger is bypassed, and the offboard, the DC charging station, they directly pump the electricity straight to the battery pack.
Okay. So now the question, I have moved some of the questions because these questions were repeating. You already answered about the where the location and all those things. So now Mr. Jayapath K is asking a question. What about keeping or parking, just parking, not charging? What about parking the EV vehicle in an basement, but not charging, just
Very good
parking?
question. Very good question. Now, this is a special case. Here, if we are parking the electric vehicle when the battery pack is in a stressed condition, it is better to make the battery pack cool by parking in a ventilated space first. But a battery pack which is not stressed, the electric vehicle can be parked in any space.
Okay, so basically you cool it down and
Yeah,
then
we
you
cool
take
it
it
down.
and keep it. If you have come from a long drive, from a drive, don't park it, don't go straight to the basement. Probably you park it outside for some time, cool it down, and then keep it in the
No,
basement. So
it's a very
basically,
particular measure. In most of the electric cars, what happens is that they have active cooling systems. So even if you are aggressively driving the car itself, the battery pack temperature is kept well under the limits.
okay, good,
Okay.
good. Okay, now the last question, during making of EV, lot of carbon emission are there in different stages, starting from raw materials to finished product. Then what could be the probable solution in order to reduce carbon footprint? Then how to deal with the problem? Share your insights.
Yeah. I have an answer for this. When it comes to carbon footprint, the most of the carbon footprint causes when it comes to procuring the raw materials for the battery pack. Now, in the presentation, I had told regarding two chemistries, right? Nickel, manganese, cobalt, and lithium ferrophosphate. This cobalt, even though it constitutes to less than 2% for the entire chemistry, the carbon footprint it constitutes the highest because mining cobalt is the most difficult. However, lithium ferrophosphate batteries are cobalt free. Now, most of the electric cars being sold in India are cobalt free. They have significantly lower carbon footprint. Now, the best measure to tackle this carbon footprint is to use batteries which are cobalt free and also give second life to the battery packs. The battery packs needn't be discarded once they are removed from cars. They can be used for any other systems also.
Okay,
Thus, the
right.
overall carbon footprint can be reduced.
Okay, right. Okay, so that was the last question. We have no idea to continue further because it's already 1 hour 41 minutes. So, participants, thank you very much for participating in today's webinar. Next week, we will be back with another webinar, but probably the subject of next week is on electric fire in medical electricity or fire due to short circuit in medical locations. All of you are aware of yesterday's fire incident in Jhansi, where 10 children were affected. So see you next time in for the next program. Thank you very much, Mr. Govind, for making a very
Welcome.
nice presentation. Probably we can have one more session covering the standards,
Definitely.
regulations part of it, so that it's clear for all the the participants. I also have a personal request. You have to share me the